video, we are going to go over how to do some logarithmic functions, some graphs, and some figuring out of the functions. So I've got the worksheet open in one window, I've got Desmos in another so that I can use that as needed. So on this worksheet, make it a little smaller so we can see the whole thing. It says the exponential function f with a base a is defined as f of x equals a to the x power. That's just an exponential function. We've used this for a while now. And x has to be greater than 0, and a can't be equal to 1. And x is any real number. Okay, so a has to be bigger than 0, a can't be equal to 1, and x can be any real number. And here's an example of an exponential function, 3 to the x, 0.5 to the x. Those are exponential functions. Now, there's an inverse of an exponential function, which is a logarithmic function. And the logarithmic function with base b is defined by the following. So y equals log base b of x if and only if x equals b to the y. So this is just the definition of logs and how you can go back and forth between exponential form and logarithmic form. Okay, so remember the log, which in this case is y, is the exponent, like we looked at in previous videos. All right, let's look at number 1. Number 1 says use your calculator to evaluate the function below, and this is known as the common log. Notice that there's no base given. Your calculator on your computer can do common logs, which are base 10. So it won't say base 10, it'll just say log, but it's implied, if they don't have a base there, that it's log 10. So these are pretty easy. You just have to type in the number and then hit log, and it will tell you that there is no answer for log of 0. So I'm going to put in the table, I'll put NA for not applicable or no answer. All right, let's do another one. Let's do 2 and find the log of 2. The log of 2 is this number, 0.301. We'll go out at 4 decimal places. 0.3010. And then you'll do the same thing for the rest of the table. You'll type in 4, then click log. Now, you might have a calculator handheld where you type the log first and then the number. No problem. In fact, Desmos has a scientific calculator, which I believe you do that way. So you'll have to figure out for your calculator how you would get the same numbers that I'm getting here. I'm going to let you finish number 1 on your own. You're just going to fill these in. Then you're going to answer these questions. See the questions? As the values of the domain increase, these are the values of the domain. As they increase, let me put in one more, 0.6021. 0.6021. Is the range, that's the y values, increasing or decreasing? Well, so far they're increasing. And so far it's not very quick. But we'll see what happens when I put in the 6 and the 8 for the log. Maybe they will increase more rapidly. That's not going very fast. They're increasing, but they're increasing quite slowly. So you pick increase and slowly. If you're listening to me, you'll have that done. All right, I'm going to move on to number 2. This is why I have Desmos open for number 2. In the same coordinate plane, sketch the graph of each function. Find the domain, that's the x values that are allowed, x and y intercepts if there are any, and the asymptotes for each graph. An asymptote is the line that the graph approaches but does not cross. So I need to type in f of x equals 10 to the x. To do the power of x, you can either get the Desmos keyboard open and choose this button, A to the B, and then type in x, or you can type on your keyboard Shift 6 to get the up arrow key, and then you can type in your exponent. The x, the variable, is the exponent. It should look like this. If it doesn't, you have something set up wrong. The domain is all the possible x values. Well, I can let x be negative numbers. I can let x be positive numbers, right? I'm going to say that the domain is all real numbers. X-intercept means where does it cross the x-axis? The x-axis is the horizontal. Let's zoom in and see if we can find it. I keep zooming in and it never touches the x-axis. It gets close. Look how close it's getting. But if you keep zooming in, it's never going to cross it. In fact, we can try to graph y equals 0, and we could try to find the place where those two intercept, the blue line and the red line. But the fact is that it will never be that. Remember what we put here? We can't find the log of 0. So there is none for x-intercept. How about the y-intercept? Does it ever cross the y-axis? Let me get zoomed out a bit here so we can see our function. There we go. The y-intercept exists. It crosses the y-axis at 0, 1, or you can just write 1 here. And then the horizontal asymptote. The horizontal asymptote is what is the line that this gets close to but never touches. I typed in the horizontal asymptote. The horizontal asymptote is y equals 0. I typed it in when I was looking for the x-intercepts and there wasn't any. Y equals 0 is the line that this graph on the left gets close to but never touches and never crosses. So now that's one of my graphs, and it says on the same coordinate system, now graph this one. G of x equals log of x. Okay, G of x equals log, just type log of x. Did it graph it? It did graph it. Look at it, it's in green down here. Look at that. This red one and that green one are mirror images of each other. They're reflected about a line. Let's look at the rest of the questions. The domain. Oh, I didn't write the range. Didn't it ask me to write the range? Nope. I was going to say that the range of the exponential function would be that y is always greater than or equal to 0. But it didn't ask me to do that. But it does ask me for the domain of this one, and this time the domain is not all real numbers because it will never be negative. There will never be a negative number here on this graph. So my domain is that x has to be positive. Or you can say that x has to be greater than 0. You can either write all positive numbers or you can write x is greater than 0. X-intercept, that's where it crosses the x-axis. There is one. There's an x-intercept on this one. But is there a y-intercept? Will this ever cross the y-axis? Never. I keep zooming in. Let's type in the equation x equals 0 because that line, it's kind of a purple color. It's right on the y-axis. And if I could find the place where those two lines would intercept, oh, right there maybe? No. When I zoom in, I see that they're really, really close, but they are never touching. So there is no y-intercept. There is, however, a vertical asymptote. The vertical asymptote is that line that it gets closer and closer to, but never touches. And I actually graphed that line in order to see if I could find the intercept, and I couldn't. And that is right there. So now you're going to answer question C. What do you notice about these two graphs? And I'm also going to get a picture of my graph and put it on my worksheet. So zoomed in here. I need to be able to see them both. There we go. I can see them both now. So you can take a screenshot of this and paste it right here. I use the tool called, I think it's called Snippet. Oops. Let me make this a little smaller so you can see it. Snip and Sketch. That is on Windows computers. You can use that tool and get a screenshot, or however you choose to get your screenshots or your snips. And I'm going to paste this screenshot into the problem. I'm going to put it underneath so it doesn't go all wacky on me. And there's my graph. I've got the exponential function 10 to the x. I've got the logarithmic function log of x, and they're both there. And I like this part because then I can see what you were working on. Or you also can use the tool in Desmos. I cut it off just a little bit here. But there's a share it button, and you can get the link, and you could put that on there if you don't want to do a screenshot, or if you're having trouble with your screenshot. After you copy and paste your link in, please hit the spacebar one time, that makes the link active so I can click on it and look and check. And don't forget, you have to answer this question. What do you notice about these two graphs? I mean, I noticed quite a few things. And when you write these things, you might notice some things are kind of flip-flopped, some inverses of each other. So don't forget to do that part. All right, number 3 says there is a special exponential and log function with a base of e that is used in many real-world applications. E is a special number like pi. 2.718 is the approximate value of it. And we call that the natural log. And we abbreviate natural log. It's kind of funny, but it's ln, like log natural. I don't know, but that's what we do. We use ln. That's not an I, it's an L. The inverse function of f of x equals e to the x power, and the inverse of that is natural log of x. So we're going to, I'm going to erase these. We're going to graph the natural log function on the same coordinate system, just like you did before. And to do this, you can type in e to the x power, and your wonderful Desmos knows that we mean that special value of e. And you can also then do ln, that's an L, not an I, of x, and it also knows that that is the special natural log function. And then you're going to answer those questions. Whoops, I got kind of zoomed out. Cut off and it pushed it way down to the bottom. So there is where you'll put those. And I thought I asked you some questions about it, but I guess all you have to do is graph them. So that'll be easy enough to put on there. Then the next part is about transformations. And I'll make another video about transformations of logarithmic functions and about this last one, which is matching the graph. Actually, you can do this now. You'll graph these in Desmos, and then see which graph matches which function. All right, I have another video about the transformation, so I'll add that about that, number 4. Thank you very much. Have a great day.